Cool. I think we're live. So, hey everyone, FusionEd coming at you. And today, I'm going to do a new weekly live stream for our bi-weekly live streams. And today, I'm going to be building Holoball. So, super excited for that. And I'll show you what we have in a little bit. I changed the environment up just so that, because actually building that environment is another half of the battle. So, kind of kept it simple. But I think this desert theme kind of works well as well. So that's what we're going to be building. And before I show a quick demo of what this is going to look like, I wanted to give two quick announcements. So first, I was at VRLA last weekend, and that was super awesome. First time I checked out the scene in VR, or checked out the VR scene in LA, and that was really awesome. Very different than actually what it is up here in the Bay Area. So that was really interesting and excited to be learning about that. And huge shout out to all the people that I got to meet that have been watching the streams and said hi. Thank you guys so much for that, because that means a lot just to know that these videos are reaching people and helping people get started. So I'll make sure to let you guys know anytime I go out to events, because I love meeting you guys, and I think that's super awesome. And the community is already like really small right now that it works really well to connect with everyone. So super excited about that. And then the second thing I wanted to announce is that when I was in VRLA, I met my friend. His name is Dario, and he works at HTC and the R&D department. And actually, let me pull up this link right now. He wanted me to just quickly mention that there's a new tool out by them called the Vive Input Utility, and it's basically I was skimming through it last night, and basically what it is, it's a nice wrapper around the Steam VR plugin, which we have been using and will be using in a lot of these streams, and it simplifies a lot of the things, like for example, like getting input, getting like your device's positions and rotation. So it looked nice. I think, let me know in the chat if you want to see like something along the lines of like comparing. I think this like complements the Steam VR toolkit by StoneFox and Newton VR, and then there's this. So if you want to see like a video or something like that comparing the three and like what are the advantages, disadvantages, put that in the chat. Be paying attention to that, because I think it's really cool that there are a lot of frameworks that are coming out now that really help support creation in a much more easier fashion than like kind of go like Steam VR is fine, but like in general, I think like having higher up frameworks is really cool too. So yeah, we're not going to be using that in this stream, but just thought I'd point it out and probably give it more emphasis later. But yeah, so switching. Let me zoom out here so you guys can see the scene view a bit better, and then pull this out. Oops. All right. So this is just going to be a quick demo of what we're going to be building. Put the Vive on. So, all right. So, come on. Cool. So we've got the paddles here. There. We'll get into how I'm controlling the paddles in a second, because I'm not doing just simple parenting with these as I usually do in a lot of streams. So I'll note that out while we're actually deving this. But as you can see, we have the ball here. Abdo built these paddles and the balls, and then we got this whole environment from the Unity asset store. So we're going to be using that for the room, and then you can download these models from our website. If you go to fusevr.com, the first blog post should have that. And actually, once I get out of here, I'll put a link to that also as well, so that you guys can go ahead and download it if you want to follow along. But yeah, so basic paddles, they're hooked up to physics, and we have the ball here. We striped it so that you can kind of see a little bit of spin, because what we're also going to be doing as part of the stream is doing the Magnus effect. So that's basically when you have spin on a ball, it'll be able to curve. And let me see if I can do that right now. Yeah, so you probably saw that right there. And it becomes more apparent, especially when I hit it on the floor. But yeah, so we also have a trail renderer on the ball so that you can kind of see the curve of it. So I think that's a really cool effect that a lot of people don't notice in Holoball, and it really makes it easy to attack the AI. But yeah, so get a nice little curve there. We put some drag on it, and yeah, you can just like this one. I didn't add any AI. This is like very akin to the Zen mode in Holoball, but it shouldn't be that hard to add AI in, and we can we can do that if we have time at the end of the stream. So I didn't know if we would have time, so I didn't actually implement anything. But yeah, basically have it so that once it hits a slow enough speed, just kind of respawns right here. But that's just basically the gist of it. And yeah, there's a little bit of coding involved in this, but we'll start simple by building the environment because there's no code to that, and do some baking, and then yeah, just do the very basics to get this up. There's actually, yeah, overall not too much code and should be pretty simple to get started. So with that, let's do what we always do and do a new project. So go ahead here, let's call this Holoball Livestream, and I will check the chat in just a second. So Abdo should be also in the chat and be able to answer any questions like with regards to 3D modeling and anything like that in general. So you can hit him up if you have questions for that. And create project. Pull up the chat now. It will be easy because it is easy. So yeah, I know there was a lot of chat. Yeah, cool. I love it when the chat's active. So keep talking with each other, and yeah, it's super awesome. And yeah, it seems like there was a lot of chat on like getting started with the basics. Um, yeah, I think there are a lot of good tutorials to get started with like C Sharp, and I think I'd recommend C Sharp for the most part. Um, but yeah, JavaScript works as well, especially if you're familiar with it. And yeah, just once you kind of like learn the basics of the editor, and then just get yourself familiar a little bit with how to actually code, then I think a lot of it becomes straightforward. And I posted this on Twitter the other day, but I really like that Unity is working on making ways that you can actually use Unity without really even coding. And I think that's a super cool feature. And so yeah, if you have any like specific questions about getting started, happy to answer those as well. Or I'm sure a bunch of people here have already like worked on like getting started a little bit. And then like once you kind of know the interface, it's like really simple to like just pick up a project. And that's kind of what I want to do with these streams is like show off a bunch of simple projects that you can then use to like get started. And I think you learn a lot in the process of actually building something, especially if you're really passionate about it. All right, so here what I want to do is I got SteamVR. I'm going to get the Desert Fortress pack. These are both free assets that you can just pull off of Unity in the asset store. And that's one of the other beauties of Unity is like you get so much free stuff that it's really cool to prototype something really fast. C# coder here. Nice, Joe. Yeah, C#. I really like C#. Like the memory management is so nice. I'm going to take advantage of that. I actually, in the demo thing, I took advantage of the fact that one of the neat things is like you don't have to do any of the pointer code. Like Unity handles that for you. So like if you have a reference, like when you delete it, like all of the references get set to null, which I think is so nice, and you can take huge advantage of that. So really love that. Seems like a couple people have tried the Udemy course. How was that? I'm kind of curious on like, did you guys learn a lot from like personally? Like when I looked at it, it seemed like it was very focused on learning Unity, but not so much on the VR side of things. So curious what other people's opinions are on that, because I think that's something to point out. Because like sure you can learn Unity, but I think one of the really cool things about trying to become a VR developer is there are a lot of VR design decisions you need to make across multiple platforms. Like Steam having a hand controllers is very different than not having hand controllers, and I think that just makes a huge difference. All right, so starting off here, I'm gonna be grabbing some prefabs from the Desert Forest pack, and specifically gonna be grabbing, I think it was, so this one, no, that's the, trying to figure out which ones I used. I think I used this one for the floor. Is that a square? No. Which one did I use for the floor? It was, the naming here is like kind of messed up. makes it a little hard to tell which ones I should be using, which ones I shouldn't. Yeah, okay, I think I used, yeah, okay, I used these for the walls and then this for the floor. So let's go ahead, drop this to 0, 0, 0. Halfway through the course, it's project oriented as you doing some simple code tasks. Okay. But as far as like learning, let's see, Durgus, as far as like learning like VR design principles, how did you think that came out? I'm curious to see like that more than just like I guess projects, but I think yeah, projects is definitely I think the right way to be learning. So let's go ahead, make a floor here. I'm going to scale this. I believe I used 3 by 3 by 3. Yeah, maybe I want this to be a square, so like maybe well actually let me line this up first. So yeah, just gonna go ahead quickly build a room really fast. Actually here I'm just gonna drag out these components because these are so the way the Desert Fortress is set up is they have it as like they separate the mesh and the collider, which I think we're not going to worry about, but that's the way they do that, which I think is kind of interesting. Go ahead, drop this to 0, scale this to like 1 by 1 by 1, okay, which is actually huge now that I look at it. I guess this is actually 10 meters, which actually we could use. I can make this a little taller at like, no, that wasn't, what did I change? That was not the Y. Which one is the y-axis? Okay, so Z is the y-axis. All right, let's make it tall, and then let's just duplicate this around a bunch. So I'm going to move this down to 0, and then duplicate this for the walls that surround us. So just doing some really quick setup here. Let's go ahead and move that here. Move this back here, and then move you somewhere around here, just so that I know the approximate positions that I should be. Let's just zoom out really fast. All right, just so that I can see the walls. Go ahead and move that here, and then for this, gonna rotate it. So just using, all you have to really do is just use the basics of the Unity interface, which I think is so nice. Do 270 on this guy, and then just line them up. So this one is going to be, let's call this 10, and then I'll call this, wow, the scales are really off actually. That's fine. We'll figure out the scaling later. Actually, no, this is way too huge. Now that I look at it, it's like this is way too huge. We're gonna fix that. Let's make this a third by 1/3. It's like sometimes setting up the environment, it's like super important to do, but like you gotta make sure the scale is right, because that is the #1 thing in VR, is making sure everything feels right. I think that when Unity releases their VR editor, that lazy. What do you mean by lazy? I think it'll help with VR development. I'm not sure I would say it would make them lazy. Like I really want to be able to go in with the actually no. I really want to go in with the touch controllers and then actually build something really cool. Yeah, that scale looks right. So just using the Steam VR prefab to basically tell me what scale I should be working with. What do I do before I import to Unity is enter. Oh, okay, cool. Blender. Blender is important. It's like, yeah, definitely hit up Abdo on all of those questions, because that is like I have no idea like how 3D modeling works in general. I need to actually I like skimmed through Abdo's tutorials, which are super cool, but I need to actually like follow along with them one day when I get a lot of time, because one day when I have a lot of time, that's the dream. All right. Okay, now that I actually have them scaled properly, I'm going to quickly build up this room. So sometimes, and like I feel like with the Unity editor, like it will become a lot easier to like build stuff like this really quickly. That's I've tried the have any of you guys tried the Unreal editor? Because I think that is a step in the right direction as far as like actually the way you should build VR. And actually, Andrew Nakas, I don't know if he's here, but he built this really cool modeling app that you can use to create some stuff in VR. And I think that's really the right approach to be using, because that basically solves a whole bunch of problems as far as like intuitive design. All right, so we got basics of the walls around us set up. Gonna scale this guy up, which is gonna be our floor, and just drag with the scale tool. Super easy. Move him. Just move this here, just because we need to get the floor. Awesome. All right, so this is just gonna make up our room. I think the size looks about right. Let's go ahead and drag our SteamVR prefab into position, which is all the way at the bottom here. Soup. How are we doing on? Yeah, okay. So this is like close. Let's like put this at 0, 0, 0, and then we can drag it and move it around from there. I'm just gonna put it like way in the back, because that's where I had positioned it before. And this is at around 1. Awesome. All right. So right now we have a room. We don't have any physics on it, but shadows are kind of not exactly where I want them. So I'm just going to take the directional light that's in a horrible position. Now that I look at it, let's move it way up here. For directional light, it doesn't actually matter where it is in the scene, which is a really nice thing. It's just, you just have it somewhere and then light hits the whole scene from that angle. So this is actually, wait, why are the shadows really bad here? Oh, that's fine. Okay, it's just the VR, the scene view is being slow to update. So we'll move the shadows about here, and then we'll move on the blue axes about here, just to get some shadows on the sides, but like nothing like too dramatic. And you can see the lines, and that's because it's doing this all in real time. And what we're going to actually want to do, and just like if you're following along, my rotation, we'll just keep this simple. It's going to be 80 on the X, -50 on the Y, and let's go with 0 on Z. So that should be about right. And the shadows here are, I don't know, they're not the greatest, but we're going to fix that. And to do that, I'm actually first thing we're going to do is go to our directional light, and this is just the one light that we have in our scene. I'm going to switch the baking to be mixed. So we're going to, basically when you do that, it's basically saying you're going to do baked light as well as real-time lights, which I think is nice. We're going to have soft shadows. We can keep all of this the same. That's not a big deal. And then we can go in here. We'll have the ambient source be our sky. I'm going to bake this ambient light also. Reflections are the same, pre-compute the same. I'm going to change the atlas size to just be a bigger atlas. Oh, I guess right before I do this. So the way baked lighting works, and baked lighting is basically what you need to do to get really high fidelity looking lights at a fraction of performance, and makes a really big difference. So to do that, we're first actually going to select all our walls, move them under a game object. We're just doing some simple parenting. So just have them all be under the room. And there's this static checkbox. I'm just going to go ahead and click that, say yes to all the children, so that all of these guys are also static. And we're basically just telling Unity that, look, this room is not going to move, and that's perfectly cool. So now that we do that, we can go into, if you don't have this tab, the lighting tab, you can go to Window Lighting. So that'll open it up. And just make sure, yeah, we want the pre-computed, we want the baked. Change your atlas size to be a little bigger. And for the directional mode, switch that to directional specular because we're running on high performance computers in general with the Vive. That's just a thing that you can expect. So we are not really limited by hardware, even though we have this warning down at the bottom. And I'm just gonna stop the auto and then say, just, oops, clear bake data, and then just hit build. And, oh, need to save the scene. So let's just hit Control S, or you can go to File, Save, and I'm just gonna call this Holoball room. Holoball room. Sometimes I forget to type. That's the thing. All right, so now we can hit build. Let that take its sweet time, and then should hopefully, assuming I did everything correctly, we should basically get a scene that looks kind of like what you saw before. You'll get some nice specular lighting. It'll have like this. These particular assets don't have a height map, but that would really make it feel like a jagged room in VR. Right now, it just kind of looks like a jagged room when you're seeing it on a 2D screen, like what I'm showing you. But yeah, no, it definitely makes a world of a difference. So now that we have that, if you look at the bottom right, it's doing those calculations. So just let that go. And I'm going to create a folder for our folder. Oh, that's what I was, for the ball and paddle. And let me show you quickly. So if we go to fusevr.com, and so this is the blog post. And if you just click this download link, that'll get you basically this paddle and this ball, which is what we're going to be using. And hey, Threshin, you probably missed the beginning, but made a shout out for the VR toolkit. And I have to show Threshin this. Threshin, have you seen the Vive input utility? I wanna know what your thoughts are on that. So yeah, so let's, I have a scripts folder here, but I'm just gonna drag and drop this FBX, which is what you'll be downloading, and drag that into the assets. So now we have the paddle and the ball, and I'm just gonna drag it off into this space here. So yeah, so this is what we're gonna be using, and I'm gonna drag, we'll call this, so it's basically a cube and a sphere, and Abdo can explain why they're that, but there is a reason behind why they're called a cube and a sphere, and I'll let him explain it. But yeah, you can just, I'm going to go ahead and name this sphere ball. I'm going to add a sphere collider to it, and I think, oh no, it does line up really well, I think. Let me hit edit. Yeah, okay, perfect. The sphere collider just lines up perfectly to that, which is great. And I'm going to drag that into our room, or sorry, no, not into our room. I'm going to drag it into our camera rig, and that's the Steam VR plugin. Well, I meant to explain that they are built from those primitives, but yeah, that works too. The renaming is one thing, but I was hoping for the cooler answer, which is that they're actually built from primitives. Yeah, okay, so let's go ahead, reset where the ball is. So if you just hit that gear icon there, and that'll center it right in our Steam VR area. And I'm just gonna drag it, move it here. So the scale is a little off on the ball, so I'm gonna have to make it bigger, which is fine, not the end of the world. And drag that up. So yeah, so we got a ball in that area. and we'll just leave it there for now. That's just going to be the approximate placement that we're going to have for our ball. And now for the, where's my paddle? Where's my paddle? Oops. Well, I just broke the prefab. But yeah, okay, cool. I'm also going to reset this to 0. We're going to need 2, 1 for each hand. So I'm going to go ahead and call this left paddle. I'm going to call the other one right paddle. So those are going to be for each controller. And let's go ahead and add a mesh collider to those so that we have the colliders. And like I said at the beginning of the stream, if we wanted, we could parent these objects. I won't be doing that, but just for demonstration purposes, I'll show you what that looks like just right now until we fix it. But yeah, so we can go ahead and do that. I'm going to reset them so that they're attached to the controllers. And just go ahead and hit play now. I think my controllers are off. Oh, it was still baking. That's why the lighting became really weird. It was still baking. We're not going to worry about that for right now. Let's turn these guys on. Oh, we can't see them because the lighting's gone. Okay, so let me set this to real time. And it was in the process. Well, okay. Let's not test that then. let's let the baking finish, and I'm actually just gonna drop this down so that the baking finishes faster. Yeah. So note to self: when it's in baking, try not to hit play because otherwise it'll get rid of all your real-time lights and then it'll make it look like this, which is interesting. Not exactly what you want to have happen, but that's fine. So I'm going to get rid of the top game object here. And so we have a directional light, we have our room, and we are, let's see, so we have the colliders on everything. Let's also add rigid bodies. So the thing about Holoball is that everything is delegated through physics. And I think that's the really neat part of it, is like you don't have to like write a lot of code. You can use, sorry, I'm looking for physics instead of rigid body. You don't have to write a lot of code. Like everything's just kind of handled through the Unity engine, which is really neat. And WebGL is a very interesting platform, I guess. That's the word I was looking for. Yeah, I could go on a rant about WebGL, or I guess WebGL for VR. WebGL is great, actually. Sorry. Yeah. Anyways, okay. So in the chat we have, what does baking do? So baking, basically what it does is, think of it as, so you have two modes. One, I can, on every frame that I'm rendering in Unity for the Vive, I can be calculating all the lighting calculations right then and there. And if you have a lot of lights in your scene, that can get pretty computationally expensive. If you don't do that, then the alternative is to do a lot of pre-computation, and just like you have textures as a way to like draw really cool, what do I want to say? Draw really cool effects onto your models. Basically, baking will calculate all the lights, see how that interacts with your models, and then based on that, it will basically create another texture that then gets placed on your models instead. So it's a nice way of getting really good lighting effects at a very cheap cost because you've done all the pre-computation like I'm doing right now. It's basically doing all of that, and then once you have that, you only have to do your calculations based on memory, which is just a lot cheaper of an effect. Plus you get shadows, as someone else was saying, which is also nice. But when you stop it midway, you get weird effects like this. And so yeah, try not to stop it midway. So yeah, let's see. Seeing how your C# code's such a So I guess while this is going, like I said, I'm gonna be adding rigid bodies here. I'm gonna take off gravity because just in Holoball you don't use gravity. We're for now gonna leave a bunch of these effects in. I'm gonna change the collision detection to continuous dynamic. And basically what this is, it's basically how specific Unity should be looking for its collisions. So if you just do discrete, it'll do it discretely, like every so often based on the frame. So it might miss certain positions where, and as a result, just kind of goes straight through it. If you do continuous dynamic, it's just checking to make sure, like, oh, if I have two objects that are moving, like if they cross paths at any point, like then they actually, some physics does get instantiated upon it. So neat thing to keep in mind. So once we have that, I'm also going to do it to our paddles here. And actually, what I'm going to do is, because I want to change the rotations a little bit of them on them, I'm actually going to go ahead and create a game object for them. And I'll build that in here, but we'll change that later. So we'll call this the right paddle, and we'll just go ahead and make sure this is at 0, and then just drag our actual mesh onto the right paddle. And for this, I want to make sure I just have a rigid body on here. I'm going to make it kinematic, which basically means don't do any of the physics calculations on it. Just treat it as if it's this thing that other things can interact with. So drop the angular, again, make sure it's continuous dynamic, and everything else here should be fine. So that's fine and dandy. We can, I'm gonna make sure the mesh collider is convex. And actually, if we go to the model, that might become more apparent. Here it is, kind of, sort of, where it. Let's focus. Yeah, okay. So there's the model. It's black right now because it's still working on the lighting. But basically, here's the difference: is if I press convex, it basically treats the whole entity as like one solid object, and then you have that extra space here, but like I think that's fine, especially like if you think of it like your hand is kind of there, so like as far as like physics is concerned, like I think this is probably the right way to like simulate like hitting against a wall kind of thing. So I think that's cool. You could leave it off if you want like to actually, basically when this is off, it's like going around like the exact fine grains of this model and like following the exact vertices. But I think for practical purposes and a little bit for efficiency as well, if you hit this convex thing, it really helps to like just create one solid mesh. So yeah, I mean, yeah, RP1 is right. Like even with continuous, it can go through, but in general, for the most part, it's fairly consistent. And like there might be cases where you want to actually test for it, but for our purposes today, it's basically this will work really well. So we have the rigid body on here, we have the paddle, we have the mesh collider. Let's go ahead and duplicate this for the left paddle, and because everything is the same, we can actually literally just duplicate it, which is nice. Go ahead, call this left paddle here, and if I can spell, it's the one thing I need to work on is my spelling, my live spelling. And so yeah, everything here should be fine. And unfortunately, baking did not take this long when I was building it yesterday. It might be because I'm also live streaming and it's eating through my CPU, but that's fine. That's not the end of the world. So we can just let that go. It'll take some time, but nothing to worry about. And so in that case, what I'm actually going to do is actually we'll work on the physics part. So scripting, I can totally wait for that, and it's not a big deal. So let's actually just like code in what we need to have happen. So the reason that wanted to show was that when I have the paddles attached to your controller, you won't be simulating physics that at all really. It'll just kind of be pushing the ball along. It won't actually be like a hit. And the reason for that is because when you parent it, even if I have the rigid body on it, what'll happen is basically it'll treat it kind of as a box and not know that the velocity is changing. And the velocity is really that transfer of momentum when I swing and then I put the ball like this. That is what causes the ball to go flying. So we basically, when you parent it, that doesn't happen because it doesn't maintain velocity in the rigid body. So you actually have to write a script to tell it to do that. So what we're going to do is just create a very simple script. So it's going to be a C# script. This is the first one we're going to build, and we'll call this set physics position. And actually what I'm going to do is create another folder just for scripts. This is what I just usually do when I'm coding. It's a nice way of basically making sure that you stay organized, and I just like to have that as a function for myself, because otherwise you'll start looking at your folder and then be like, what is going on? Because I'm just like, too much stuff eventually just accumulates. I kind of felt like that happened with this project, but that's fine. So let me go ahead here and let's go ahead and create a rigid body. Sorry, not private or not public. Let's go with private. This is just going to be our reference to the rigid body, which is our paddle. And let's also create a public reference to the SteamVR tracked object controller. So we're gonna assign this within Unity as our controller. So have a basic, that's gonna be a reference, and then this is the rigid body. And we're in the start, what we're gonna do is call get component rigid body. That just gets us our reference. We just have to initialize it. And then here, what we're gonna do is call r.move position to controller.transform.position, and we're going to copy this, and then we're also going to do move rotation. So what this is doing is basically just copying whatever the position of our controller is in 3D space, and then moving our paddle to that position. And by doing that, especially because it's changing on every frame, it'll also be calculating the velocity of the paddle, which I think is just all you need to do is just these two lines, and then once you do that, you'll basically have the physics simulation within Unity calculating that. Let's see. I'm just gonna quickly go through the chat. Yeah, I don't know why. I can honestly, it's stuck at 5 jobs, which I don't know why. Let me go ahead and cancel this and then drop this down to 10. Keep the compressed, the padding's right. Let me drop this down to low resolution just for the purposes of the stream. And let me, yeah, okay. Hopefully this is faster. Fingers crossed. Maybe. It's at 5. Still stuck at that clustering. I'm not sure what's going on. Fine, okay. We're not going to do the specular. If you want it to be even more efficient, go to non-directional. These are basically different layers of like how. Oh, you know what it is? The one thing I forgot to do is actually go through here, and the Desert Fortress is actually using your like a old shader, so that could actually be it. So just go ahead, quickly change these shaders to standard, and it'll keep all of the settings the same, but that might help it go a little faster, or not. I don't know. It'll take its sweet time. That's fine. That's part of baking. This is weird. I can't remember it being stuck like this. That's the strange part. Okay. Forget it. I'm just gonna clear that. I'm gonna switch this to be real time and then save the scene and then just reopen it. Let's actually go to new scene, go to problems with baking. Fine. We'll super saturate the scene then and get rid of shadows. All right. So that we can at least see some stuff. I'm just gonna get rid of shadows for now, and we'll bake it at the end. Hopefully by then it'll look cleaner. But yeah, okay. So let's just make sure on both of these paddles we have our set physics position, and then let's also go ahead and drag our controller left onto the left paddle, and then on the right paddle, drag controller right onto it. So have both of the paddles, and now in theory, this should, all right, cool. Should get paddles that are tracking somewhere. I see the controllers, but where are the paddles? Oh, the paddles are just super tiny. Well, we can fix that. That is the beauty of testing, right? So yeah, this is one of the reasons why I wanted to actually test this. And so we're just gonna make, I believe I used 30, 30, 30 for the size of the paddles. Just go ahead and do that. And then what I'm also gonna do is move the paddle like a little, oops, not that, I'm gonna do it on local. I'm gonna move it a little north of here, just so that basically when I hold the controller, basically it'll look like I'm holding the paddle. And that I think feels a little more natural because that's kind of what you do in the real world. But I also felt that at least I also feel this in Holoball, but I feel like it's a lot harder for me to hit the ball when it's not centered on my paddle. And let me ask this for the chat: have you guys, well, first, have you played like Holoball or like selfie tennis? And then do you also kind of find it that you occasionally miss? Those are two things that I've noticed, and just kind of curious to see what other people's thoughts are on that. But yeah, so that's the basics, just kind of making sure this is set up right. We're going to copy the transform. You can play around with this, just like the sniper tutorial that I did. You might want to play with the rotation of the paddle relative to controller. And the reason for that is when you rotate it, it might feel a bit more natural, like because your default position is like this. But for this, like I still need to experiment a lot with actually what makes sense. I'm not 100% sure. But so yeah, for now, I'm just gonna go ahead copy this because once we stop hitting play, we'll lose the transform data. So for both the left and right paddle, I'm just gonna select them in the hierarchy and then paste those values. And so now the size of the paddle looks right. And again, lighting's not great, but we're gonna have to live with it. And yeah, with that, in theory, I should have. Yep, there we go. And I think I hit my control. I hit my. Yeah, I definitely hit the laptop. But so we'll move the ball back so that doesn't happen again. One of the things you got to be careful about with VR, right? And let's move this back here. Now, what you probably noticed was. Yeah, exactly. Great sound effect. I planned. Definitely planned. Cool. So one thing you probably noticed was that the walls, the ball went straight through the walls, and that's because we actually just need to select all of these things and add box colliders to them. And yeah, they all have their own different positions, but that I think should be fine. Yeah, should work. the better question is, what does that? Yeah, okay, cool. You can see that green outline, that basically that's the box. And nice thing is Unity already calculated the size of the mesh and then selected a box collider around that, which I think is very nice. And so yeah, so we have, now if I actually go in and do it, that should, oh, whoops, I forgot to add a collider at the top. Let me first show you that this works. And bounces off, it should bounce off there. And it's just, yep, there it is. It's really tiny, but yeah, that is happening. And what to actually like make it more obvious, what I'm gonna do is add a trail renderer to it. So trail renderer is basically just a way to, like, if an object's moving, it'll automatically put a line behind it. So it's a really nice effect, and that we saw that in the demo as well. What I'm gonna do for this is actually quickly create a material. Let's call this trail mat. I'm gonna make it unlit color, and then just make this red. So the reason I'm doing it unlit is, one, the lighting is really wonky right now, and two, it'll actually look weird, like even with the right lighting in. So just gonna drag this material that we just created, put that in here, and we have, I believe what I used is, we're gonna start with 0.5 and then go down to 0.1. And so that'll just kind of get that like funnel looking effect to it, which I think are, yeah, funnel looking, I guess if the ball is here. So funnel out. Or yeah, no, it should be the other way. Whoops. It should be the other way. Yeah. So yeah. And yeah, now we should hopefully be able to see it a lot nicer. Yeah, there we go. Obviously, that trail render is going for a long time, but we can fix that easily. I believe it's the time. I mean, what did I think I put 0.5, just 0.5 seconds. So it'll last for 0.5 seconds and just follow along with it. Where did the ball go? Did I already hit the ball? Whoops. Okay. Yeah, there we go. So yeah, so now it just follows along with it. And it still feels a little small because I think the room is too big. So I'm just gonna shrink the room size to like a half the size. I think that might be better. Yeah, that feels better. And yeah, for some reason it looked the same as in the headset, which I think was strange, but, or like what I was used to, but that's fine. It's just, you can see the trail render already working, which is nice. Yeah, so let's do this. Hopefully the baking actually would be faster if it's smaller. Let's see how that feels scale-wise. Yeah, still kind of feels the same. Controllers, there we go. But yeah, the ball definitely, we could actually probably go a lot smaller with the ball, but yeah. Let's quickly add what we're gonna do is quickly add a collider to the top so that it always stays within our area, because that's kind of important. To do that, we'll just go to the room, and let's just call it ceiling. And then here, gonna add a box collider. And I don't know where that box collider is, but whoops. Oh, I didn't add it. Okay, that would explain why. So let's add a new game object. I clearly didn't do that, which is odd. And let's move it to the top here. You don't really have to do this, but I think it makes it easier to explain things. If I move it up around here, and then let's just quickly add a box collider. I'm gonna go, this one should be really small. You can see it right here, but I'm gonna just quickly go ahead, hit edit, and we have these nice knobs that I can just drag around and just make this look a lot longer than we want, or like a lot. Yeah, this would just be so that the sizing is right. and you can also just like change it here. So like if I want 50, or so that's the center. So if I want, let's make the center 0 and then the size like 100. Well, that's too small. So let's go with maybe 200. And this one can be big. We don't actually have to have it fit exactly. The reason for that is because even if it's bigger than the whole size, you're not going to see it. Let's just, yeah, so let's just go 200 by 200 with a height of 1 because that doesn't matter. Size-wise, actually, I mean, we can go a little, let's go maybe 5. So just get a nice box on the top. And that'll just keep the ball inside. So that's really neat. And so yeah, so now we can hit the ball, it'll bounce around this room, and we can control that with the paddles. So the very basics of what Holoball is now implemented. The next step is actually playing around with physics, because right now it doesn't feel right. And the reason is that everything's moving a lot slower than it needs to, and that's just because the default Unity settings for a lot of things is just not what we want. And Sing has been begging for more of your attention. Yeah, I know. I don't. Okay, what do you guys think should be the ceiling? I just kind of left it with a collider when I was testing, but I didn't know what makes sense for the ceiling. So yeah, let me know what you think there. I mean, I didn't want to throw like a basic wall on the bottom, but yeah, not really sure what made a lot of sense to actually put up there. So yeah, so box collider on the top, and let's just go ahead and create some physics materials. So physics materials are what's going to allow us to basically control how our objects interact with each other in a way that feels a lot more peppy and vibrant. So for that, what we're going to do is first create a material for the, or is it physics material? Let's create a physics material for the ball. Actually, again, I'm going to create a folder for this because physics mat. And so basically what physics materials are they can, so I think more than me explaining it, it makes more sense to actually look at it. So basically it controls a bunch of different properties of how an object interacts with the world. So that's friction, static friction, bounciness, and like how those things are calculated when it interacts with another object with a different set of materials. So for that, what you're going to do, what we really want is this bounciness needs to be set to, on the ball, we'll set it to 0.5 actually. And then we'll do the bounciness combined as maximum. So what we're saying there is, again, it's exactly what you think it'll be. Like bounciness is like it hitting the table and then bouncing off. So like how much, I think this is based on like the spring coefficient, but like it's basically like how high it should kind of pop, or like how much energy should it lose when it like hits and bounces off. So that's obviously super important in Holoball because that's actually what we're going to be using to like calculate bounce. So I'm going to leave it for 0.5 for like when it interacts with walls, but like when we say maximum, it takes, if I have a paddle and the ball, which is at 0.5, it's what it's going to take is the maximum of 0.5 and whatever the bounciness of this paddle is. So if I set the paddle to 1, which I'm going to do, then it'll bounce off using the bounciness property of 1. If it was less than 1, then it would use, or less than 0.5, which is what we have set for the ball, then it would use the value of 0.5. So it's basically combining, because in physics, the physics material is always indicative of what two things it's interacting with. So both of them have different properties, and by using this combined feature, you basically are saying that these are how the properties should interact. So I'm going to take the maximum there, and also for friction, I'm going to take the maximum. So both of those, super important, and really dictate how your objects interact. For friction, I'm going to actually drop this down, but this is also important. We'll be using this a lot later with the Magnus effect because the friction is really what allows it to get that spin property and then kick up a Magnus effect. So simple example of 3D lerp. 3D lerp with the ball or 3D lerp with, yeah, Joe, just let me know 3D lerp with what in particular. Because lerp is awesome. Lerp, it's simple but awesome. That's what I gotta love. I gotta love lerp. So these are the properties I'm going to be using for the ball. And to just assign it really quickly, we have our sphere collider, and then we just drag and drop this onto the physical material. So nice and simple there. And we actually, well, we could do a lerp with it, but we're actually not going to need to because all of it, like the nice thing is that all of it's just handled by the physics engine, which is so, I think it's really neat. Like you don't need to, like, all the smoothing is handled by that. It just, you hit it and it goes. And I think that's really cool about it. So let's also create a material, whoops, not a flare. Flares are cool, but we don't need flares today. And let's also create a material, or a physics material for the paddles. Paddle, sorry, paddle. Here, I'm actually going to set, these are the parameters. I'm going to be using 0.7, 0.3, bounciness of 1. And because we're using the move position, none of these properties are actually going to matter for how the paddle is affected by physics, because we're basically saying that you're always going to move to the position of the controller, and you just have to calculate the velocities for that. So, but for simplicity, I'm just going to set this to maximum just to be consistent with the ball, but it really doesn't matter at all. And so yeah, so for those, we have our mesh glider. I'm just going to drag the paddle here, and that'll control the bounciness there. And so now, whenever the ball hits our paddle, it's going to be set to a value of 0.1, and then just, or sorry, it's going to have a bounciness of 0.1 and just fly off, which I think is just really cool. And I think the last thing, I actually don't have this within the demo scene that I created, but what you can do is you could also create a physics material for the wall. So I'm just going to leave it actually at the default values that it has, which is, what are the default values now that I think about it? Physics material, let's call this wall. So I think that it's using 0.6 and then a bounciness of 0. So like, I think that's fine. We don't have to worry about the walls too much. And yeah, I mean, that's more than enough. So now let's actually go ahead and test it out. This lighting is killing me right now. I'm not gonna lie. We got our paddles, so now it should. So now it had a bit more spring to it, and yeah, I'm gonna actually drop down the. So here are a couple things I noticed. So one, actually just looking at the ball, and you probably see this better within Unity, is we do have some spin to it because of. Oh, lighting is really killing me. I can't really see what's going on that well. But yeah, okay, there you go. There's some spin on it, and that's because of the friction. The bounciness came off. It felt a little bit stronger than what we initially had, which is nice. And I wasn't swinging terribly hard because I also don't want to hit the laptop here. But that is also a nice thing that we have. So what we need to do is a couple things. So one I want to do is just for testing. It's testing purposes, but also just it's a nice game mechanic in general. Is being able to, when the ball dies down in terms of velocity, being actually able to just kill it and then respawn it right where you are. I think that's just nice in general to have. And then two is adding the Magnus effect. So those are like probably the two things that I want to have to do. And we will, I think some plans, but been about an hour, so I think what we'll do just to have get people to catch up in general if you're following along, I'm going to take a quick like 5-10 minute break, jump into Holoball, and then we will do, you can catch up, and then what I'm also going to try to have happen, fingers crossed, is have this stupid lighting actually bake itself. That would be nice. So let's make sure this directional light is set to mixed. I'm gonna turn on the shadows, and then fingers crossed, it should bake. So what we'll do, yeah, so let me jump into Holoball now, give you guys a 5-10 minute break. I'll point out some couple things, like especially with the Magnus effect, and yeah, have some fun. Hopefully, if we're lucky, the stupid thing will actually finish baking. I did not have issues with it taking that long last time, so I don't know what the deal was. But let's go ahead. I'm gonna plug in some audio and just go ham. Keep that here. Yeah, I probably didn't take a look at the chat, but I'm curious, how many people have played Holoball before? Because I know a couple people had asked. That was sad. I know a couple people had asked for a tutorial on how Holoball works, so that's why I definitely wanted to provide this. But I'm kind of curious, like, if this is a game a lot of people play, or like, if it's just kind of too pricey that people don't look at it. Let's grab the controllers and make sure to actually put the straps on, because I don't want to be throwing these controllers out the window. I'm on the 2nd floor right now, and that sounds like it would be disastrous for the controllers. Let's see, there we go. There we go.
Greetings, human. Choose your weapon.
What do I want to play? Kind of feeling. Let's go Zen. There we go. I know that was definitely weird. Let's see. So, nice thing about Zen is you have a bunch of different properties. Set bounce speed, which is I think when it bounces off of the back wall, and the ball size. Let's go with 0.5. Go with a bigger room, just to like fit things around. Ooh. That felt a little small, but you can see the Magnus effect a little bit. And what I just realized is I've kept saying the word Magnus effect without saying what that is. Basically, Magnus effect is. I don't have space. I should have run room scale setup, but Magnus effect is what it is. Basically, is that when I spin the ball, you have air. The air basically acts on the ball to get it to spin up or down. It's what you see a lot with tennis, really. It's really loud. The other thing I'll point out is the ball actually does this. Every time you hit it, it has an emissive property, so it actually kind of emits light, which I think is also a really nice effect. And it's actually surprisingly cheap, which I think is also really cool. The other thing I like a lot with this is basically being able to hit the ball without, or like tap it lightly, like when it spawns here, popping it up, and then like kind of doing a serve almost. I think, especially when you're in a competitive one and trying to get aces, like that's the way to do it. So we'll make sure we have that in. I'm being like super careful right now. You actually don't see the spin on the ball all that much, but it's still like no. Also, I'll also point out, and we'll add this in also, but when it bounces off that back wall, it actually they do some nice, like it feels natural, but like none of the physics is right on it. Like that bounce right there was not straight at me. It's basically kind of doing this like random generation to my area, so that it just comes straight back at me. And there's no spin or anything like that. You lose everything. So we'll add that in. That's what I was talking about. It like sometimes just goes through my paddle, and I don't think that's a physics issue as much as like this feels like a design issue. Like it's out here and it doesn't really hit my paddle. But I don't know if like people have played Holoball and like seen that before. Because that I think is a huge issue for me. Yeah. Yeah, I should have definitely learned from that. That was a mistake. I'm so used to not running it and just being like, oh yeah, I'll just do it kind of standing. That'll be fine. It's like, no, no, this is not fine. But gotta make do. It's actually still really relaxing. Oh, that was such curve. What is my type? I forget what. I think a lot of people have played it. 1331 on looking at the daily champion board, it's like 1331 for today. That was like literally in the last 10 hours someone got 1331. That's crazy. That's seriously crazy. I mean it's awesome, but crazy. I'm assuming it was someone from Europe. So I think everyone in the US is still probably. Can't really do anything on that side. I don't want to kill you guys or the computer. That would be sad. That would be really sad. I'm already. Someone please get me off the leaderboard. I find that kind of sad. That was a 21 and a half, and only playing on half the room. That seems really disappointing. I'm actually even surprised that I got 21 in the first place. Oh yeah, I totally forgot that this one also has a trail render. You guys are at all interested? I think the ball uses the same trail render as this. And someone correct me if I'm wrong, but I believe this is built in Unity as well. Or at least the trail render looks like it was. But again, that could be. And yeah, definitely as you can see, it's like around. It starts at like about 0.5 and then goes to 0.1. Or even maybe potentially 0. I'm not really sure there. But you can clearly see the fade off like that. Whoopsies! Most of it's generated by physics, but a lot of it is something I noticed. Let's just help for next time and definitely make sure to do room setup. A lot of these games, they don't. Or that they require it. And it's really, really bugging me. Although this is so nice. Alright, I'm gonna attempt to get to 15, and then we'll start back up again. Hopefully the baking is done. I just realized this. They do, when you do return the ball, it's based on like, how hard you hit it back. We're not going to code it that way, but I think I got one more shot. There's some guaranteed 15 according to how long I can last for. No, get on to the other side. No, stop it. Get on to like this side. I can't hit on the left. Like, not only am I handicapped with the fact that I'm not left. Alright. Alright. Back to the tutorial. But yeah, no. The Zen mode is definitely Zen. That's for sure. Like you the ball into the wall. I don't know how many people growing up like had wall. Like what was it called? What was the game called? Not Foursquare. That was the other game I used to play as a kid. I can't remember what the game was called. How was that? Not sad. Oh, yes. All right, beautiful. All right, this is non-directional, but that's fine. At least the baking finished, which is what I wanted to see. And yeah, nice thing about baking is basically what it does is it really lets you get that indirect light bounces. It's able to do that because you can't do that in real time, and it just looks a lot more polished. Obviously, if you do, non-directional is the simplest bake possible, and it works really well on mobile. But when you go to fancier things and you have more time to actually bake something, definitely try out directional or directional specular, as they just look a lot better. But yeah, no, I'm glad that finished because otherwise it was sad times. So yeah, let me actually move this into the sun because I think that'll just look nicer. You can leave those where they are. Um, that is awesome. That's what I want to see. That yeah, I mean like one of the things. Yeah, thanks Russell for mentioning that because yeah, like definitely one of the things I want people to think about, at least with VR tutorials, is like you definitely should. There are VR design principles like just because you're a Unity developer, you're close to being a VR developer, but like there are things you should keep in mind. So glad that people are like taking some VR tidbits from it because I think that's awesome. Um, but yeah, so first thing is what is the first thing I want to do? First thing is we'll do the ball spawning, and then the second thing will be Magnus effect. Um, and then third thing is just the wall hit back. That is the third thing. So let's go ahead and do the ball spawning. So that's actually really easy. Or yeah, it requires another script, but nothing terribly complicated. So let's call this the ball manager and click that. Reload, fine, whatever. I don't know why Visual Studio always asks me that. So for this, what we're going to do is just create a ball prefab. So prefab is just something we'll store in the file, so something really easy. For that, now that we have the ball prefab, all we're really going to do is have another variable for the game object called current ball, and just get rid of start. I don't think we need start. And then update, all I need to do is say if current ball is null, then current ball equals instantiate the ball prefab at our position and transform. So you could also obviously like specify this like within Unity, but what we're going to do is basically, oh yeah, and then I also need to say as game object. All we're doing is basically we're going to put the ball as a prefab. We're going to say create the ball every frame, or like if the current ball doesn't exist, and not equals, and spawn it exactly wherever the script is in our scene. So let's go ahead and hit save. I don't know why it's not saving. Strange. So let's see, where's the ball? And let's go to the inspector. I'm going to create a game object exactly where the ball is. So that was a win. Yeah, perfect. We'll call this ball manager, and then we'll just drag our ball manager script onto there. I don't know why this is not saving. That's bizarre. Bugs. That's all I'll say. Bugs. Yeah, save all. Okay, fine, whatever. So that should hopefully update so that we can have a ball. Yep, ball prefab. I'm gonna create another folder for ball prefabs. Go ahead, drag our ball down here. We can get rid of it from the scene now. Don't need it. And then just drag that in. So basically all we're saying is every frame we're just checking, make sure the current ball doesn't exist. If it does, we create it, and then the thing we have to do is just delete it if it's going too slow. And that's also, again, super simple. So I'll just create a script here. Let's call this, we'll just call it ball. And it'll just manage the behavior of the ball. Specifically, just like here in the set physics position, I'm just going to go ahead and copy this rigid body stuff because we can just reuse that. Same thing with the start. And then all we have to do actually is if r dot velocity dot magnitude is less than some value. This is something you probably want to test out. I'm just going to hard code in like 2.5 for now. Then we'll just say destroy this dot game object. And we have to say this dot game object instead of game object, or instead of this, because this is actually a reference to the script, and game object is actually the ball is the idea there. So we just need to assign that to our ball prefab, which I can't. Where did I save it? There we go. Why did I? Let me see. Let me just rename the folder. I usually don't just have ball prefabs. I just have a prefabs folder in general. You can organize however way you want to. I'm just going to organize it like this. And so yeah, so if the velocity is less than 2.5, which we'll need to fix a timing issue for that. But if it's less than 2.5, then we destroy it. So actually, what'll happen here is actually as soon as we create it. So this is something just to point out. As soon as we create it, the velocity will be less than 2.5, so it'll delete itself. So you have a couple options here. What you can do is do a void on collider enter, and this basically detects as soon as our paddle hits it, and then we can set a boolean here. So what we can say is private bool is hit, set that to false, and then is hit equals true. Then we can say and actually we'll do it in front, and we'll just say quickly here is hit and end. So what we're doing here is basically as soon as we're hit, then we'll just make sure that the velocity is less than 2.5. And right, okay. There's actually a bug in here, was what I just in all of the things. So actually, I'll mention this now, but in general, when you're doing any physics manipulations, what you're going to want to do is actually put them in fixed update instead. And let me pull up the documentation for that because that's actually pretty important, and I just completely forgot about it until just now. But if we just like Google fixed update for Unity, it says explicitly right here, fixed update should be used instead of update when dealing with rigid body. For example, adding a force, blah, 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 blah. But anytime you touch the rigid body, you should be using fixed update. I forgot until just now, and that can introduce weird bugs. So just keep that as a reminder in your head. And we can do it in fixed update here or update. Really doesn't matter because we're not updating the velocity. But I'm going to do it in fixed update here anyways. Let's see. A lot of you smart earlier. Thanks, Joe. Appreciate the support, man. Hit the save. Yeah. Okay, cool. Just quickly reading through the chat right now. Cool. So yeah. So that's fixed update. We have the ball now, and collider is true. So now if I actually jump in here, now that we have everything hooked up, so it should create the ball, and I'm just going to hit it. And so hopefully, if it slows, once it slows down, Oh, I didn't add any drag to the ball. So let's actually quickly do that. I believe the drag, let's go with 0.1 here, and let's go with the angular drag of 1. So drag, if you're familiar with physics, is basically all you're doing is, let me move this up actually. So drag, all you're doing is basically have the speed of the ball, and like if the ball is moving, like air will slow it down. So just using drag to like slow everything down really, so that it actually does slow down. And just specifically just to test what did I? Okay, I hit it way too hard. That is what happened. Okay. So now it should be slowing down, slowing down, slowing down. But the is hit didn't get triggered. Why didn't that get triggered? That's strange. Maybe I spelt it wrong. On let me quickly make sure. On collision enter, sorry, not on collider enter. that would explain it. On collision enter. Sometimes when you think you have everything by memory, you don't. All right. So now the drag should. There we go. Perfect. So like now when it slows down, come on. Because of the drag, then it falls off. The drag is, it's a different coefficient. The drag is, it's almost more static. It's basically whenever it's not hitting anything, then it's slowing itself down. The friction is more when, from the physics materials, it's like when two objects hit each other, how spin and speed transfer is calculated. So that is, I think, the way I would differentiate friction from drag. Like drag is more often being used. I'm actually going to drop the drag down to 0.1 just so that you don't have that. You can at least hit the other wall before it stops. As for drag, angular drag, we'll keep that at 1. Let's see, gravity, kinematic. Yeah, I think that basically does it for spawning the ball. And then the only thing we really have to do is we'll just write the last script that I want to write. Is that the last script? No, 2 more scripts. One is for the Magnus effect, and then the other is for just actually playing the game. So for what we're going to do here, we're going to create just a quick hitback script. And we'll attach this to the back wall. And basically all we're going to do is, we actually don't even need this stuff. All we're going to do is like when the ball hits us, then we're going to send it flying back towards the headset. And the reason I'm saying headset is because that way it's, one, I know I can hit it always. I think you would in general want to like put it in a kind of a random box, but the headset's just a really fast way for testing. So we're actually just gonna get the transform, and then we'll call this head, and we'll do let's just copy our on collision enter script here, and copy that. Perfect. And so here, what we're going to do is we're just going to assume that it's the ball. Obviously, if you're being more rigorous, you can always check that it's the ball. But on collision enter, we're going to assume the only thing that would have hit us is the ball. And what we'll do is we actually just want to get a reference to it, which I'm just going to, since this is a ball manager, I'm going to actually treat it as a singleton. What that means is basically we create a static reference to the ball manager. So specifically call it instance. And you'll see this a lot with Unity programming. I've done it a couple times in my videos as well. But all you have to do is, as soon as the script is created, just make sure like if instance equals null, instance equals this, and likewise on destroy if instance, this is again just sanity checks, instance equals null. So yeah, awake, destroy, we have our instance, and then I'm going to make this not a public variable. Actually, no, we'll do a public variable, and then just, again, this is hacky coding, but like, if you're just doing fast prototyping, like this, I think is perfectly fine. Hide an expector, current ball, awake, destroy, done. Okay, that's that. And so yeah, so we're just going to say ball manager dot instance dot current ball. So that's the current ball, and then we're going to get the rigid body component on it. So there we go. Let's call this. I'm just going to be lazy with my naming today. Actually, I'm lazy with my naming in general. We'll call this rigid body R, and for this, we're going to set the angular velocity to 0. I'm just going to basically remove the spin exactly like what Holoball does. And we're going to set the velocity. So we're going to first calculate the direction. So let's call this, the direction is basically from the ball to the head. So head dot position minus r dot transform dot position. So we're basically saying this is where my head is, here's the ball, and then drawing a vector to that. And we're actually also going to normalize that. And that's also really easy to do. So normalized, just so that we have a direction for that. And then we're just going to set the velocity equal to dir times whatever value you want to do for the speed. When I was testing, I just tried. You can make this a random number. You can make this whatever you really think adds to your effect. This is the part where customization really kicks in. Just set that velocity so that it at least comes back to you before it drops down to 2.5, and it feels fun. So that's the game design component of it. So I somewhere between, I think 30, 40 works pretty well. So that's like fast, but not too fast. And yeah, that's pretty much all you have to do for the ball rigid body. Just make sure that angular velocity is set and the velocity is set, and it'll come flying straight back at you. Yeah, collision collider, that naming needs to change at some point. But yeah, so that's the hitback script. We just need to attach that to whatever wall we want to do that, and specifically this. It's going to be the back wall that I just clicked on, and just make sure that's set. We, I believe, also need a rigid body on this guy. So I'm going to make it kinematic, set this to 0, and again, we don't know what the speeds are going to be like, so I'm just going to set the detection to as high as possible. And yeah, that's pretty much does it for the hitback. Let's test that out. Get rid of that. And this one fell asleep. All right. So assuming that hits back. Yep, there we go. 35 seems a little small, but that's fine. There's a little bit of spin on that guy, but then all the spin kind of goes away. You might want to make this room a little smaller, but like that's again fine. And now, yeah, this is very basics of Holoball right here. So that's pretty neat that we're like kind of already this far. The only really other thing that we want to add is the Magnus effect, which again is a really small. Like I said, the Zen mode just like it's so relaxing. I don't know why. I was just like in the zone, hitting the ball back and forth, not really putting a lot of effort, but I think there's something about it. I don't know what it is. Yeah, so let's just do the last thing, which is the Magnus effect. And so I actually, if you just Google, honestly, so here, if you Google Magnus effect Unity, this is the video you want. It's called Learn to Code. It's unclear why the name is the name it is, but in it, if you go to like 2 minutes in, it talks about the Magnus effect. And specifically, it's really simple. It's you have some constant, and then you just do the cross between the velocity and the angular velocity, and that creates a Magnus effect. Woo! And you just throw a constant on top of it to scale it appropriately, and that's pretty much it. So super simple. So let's again just create our final script, which is going to be C# Magnus effect. And here, just hit reload, get rid of start, and oh wait, no, we need it. Actually, no, you could. So this code you can actually throw within the ball. I'm gonna actually go ahead and do it within its own script. I was double checking myself to make sure. The reason is you could do the Magnus effect on pretty much anything. It doesn't have to be the ball. So just for like being able to reuse it in cases where you may actually want to, use it on a ball, I'll just write it here. Again, we're just going to do fixed update because this is actually adding a force to it. And we're going to want a public variable here for the Magnus constant. Public float Magnus const. I don't remember what this was supposed to be set to, and I might have to cheat and look at what I set it to. But let's just quickly create a, let's call this force equals vector 3 dot cross between r dot velocity and r dot angular velocity. Just exactly what he has. We're going to multiply it by the Magnus const. Adds that, and then the way he applies it is actually r dot add relative force, and then just add the force in force. And I think if you like just scroll, let's see where he adds it. Yeah, he has the resolve. Let's see, does he go down? Well, somewhere in this video he shows that he does use add relative force, and I'm not going to worry about it. But what I do want to show is what he uses for his constant, and he uses 0.005. I'm not sure what the exact physics behind it is, and you can play around with this value. I'm not doing any of the vector math. This is purely just finding code online and using it. Like that's all that is to it. Nothing terribly fancy. There are resources, and I'm no math genius. I just know how to tap into resources. That's all I'm doing here, and anyone can do that. That's the beauty of it. So yeah, we have this. I'm gonna quickly check what I used as my Magnus force in the code I wrote somewhere here. Let's just open. Oh, that's gonna open up in MonoDev. Oh, that's fine. I use 0.07. We'll use 0.07. That works. Let's go. I used a value that's bigger. That's fine. So I think, yeah, just for kind of the friction and stuff we're using, like 0.07 might work. Again, play around with that value. Play around with the friction values because that's going to affect your angular velocities. And yeah, I mean, we just have to add that to the ball somewhere. Where's my ball prefab? All of the prefabs. This is what I'm talking about, organization. It's nice to see the folders here and then just be able to like, oh, okay, cool. That works. Yeah, set to 0.07. And that's pretty much it. Let's go ahead and try this out, see how it feels. And of course my controller's just died out just now. I might have to move this back. That's fine. Let's see. Yeah, that curved. We definitely saw it curved. And yeah, I mean, now we're pretty much at whenever the drag, I'm going to make it a little more just so it dies down a lot faster, but that's not a big deal. Probably set this to 0.5. Um, but yeah, we have spin. You can definitely see the curve now with 0.7, but it's not like crazy. And that's just gonna bounce off. I don't know if it's gonna reach. No, 0.5 is too much. Note to self, 0.5 is way too much. I mean, that's also, these are just fine tuning parameters at this point. Like that's, let's try maybe 0.2. I don't know. Yeah, I mean, at this point, it's really, I don't know how I want this. Yeah, it's spinning. We're gonna die out really fast. I know it is. Come on, hit it. Yeah, no. Okay, fine. Oops. As you can see there, as someone said, it's not perfect as far as like hitting it, but with the collision dynamic, like it gets it 99.9% of the time. There are very few cases where you'll miss it. Yeah. You might want to make the 2.5 a little longer so it lasts longer. You can also tune that based on you can tune it based on a bunch of different things. I know the Holoball ones are very specific. Also, like for Holoball, there are times where you want to like tap it and like set it up. So you can add like timers in so that it's not just like doing derpy things like this. Is because of the velocity not being fast enough. So like yeah, like those are a bunch of different things to tune as far as like the game is concerned. But those are all game design mechanics, and that's something that a lot of people can play around with and get looking nice. Um, yeah, I'm also gonna what I'm gonna do. Ow! It's weird when the ball goes through your face. I will say that much. Um, and yeah, as far as like the AI, also like the AI for Holoball isn't terribly complicated either. It's like you know where the ball's velocity is going to go. You might not be able to track like bounces all that well, but like you can say, here's where the ball is, here's where the velocity is. Okay, so this is where it's going to hit the wall. I'm going to move my AI there. Like that's pretty much all you would really need to do as far as the AI is concerned. Another thing, so when was this? This was about 2 weeks ago now. But I'll make another video on this separately. But what I want to show is here. So about 2 weeks ago, John Carmack posted on his Facebook a huge post on how to like why you should do anti-aliasing in VR, and like there are a bunch of like optics reasons for it and like display reasons. And so I just wanted to quickly show where that is within Unity because he was talking about it at like the OpenGL level, which I think it's great, but the thing is not like the reason he can complain is because like if you don't show how to do it in Unity, then and a vast majority of people are doing it in Unity, then people are just not going to do it if they don't know how to. So saying it at the OpenGL level doesn't really make much sense. But just to quickly show where that is, if you go to projects and then quality, it's all here. You can delete levels that you're not using. For Vive, you should be using like this fantastic quality basically. If you have a lot of real-time lights, set this pixel count up high. He wanted people to be using this 4x, so use 4x. Um, make sure like these settings are fine if you want hard or soft shadows. The 4x will really help. You can even go to 8x, but like that's a higher performance cost basically. Um, and this is all pretty much only for the real-time lighting. The baked lighting that we did and finally actually ended up finishing is that you don't really have to worry about. Like that'll come out and it's textured on. You will have to worry about a little bit about the aliasing because they are textured, but you won't get those like really jagged lines like you do with the real-time lights. So just wanted to point this out here. Because it is really important. But yeah, I'll make a separate video on this, but because that's just kind of a big deal. as far as like VR is concerned in general, because you do want the high anti-aliasing. And yeah, that's pretty much all there is to it. As far as like what we built in the demo. If you guys have like specific questions or anything along those lines, like other stuff you want to see or anything like that, like definitely let me know. And meanwhile, I'm just gonna skim through this because that is awesome. Option go up to wait. Oh, badass computers. 1 terabyte of RAM is a lot. That is crazy. Um, yeah, what what I really want a badass machine for is to render out some live stream. I want to be able to live stream in 360 from Unity. That would when that's a reality, I will be so happy. Because you basically I think like 360 is really nice to like help like show some of the design details that you don't actually get to see just from the flat screen, unless you're following along, and then you'll be able to see it. But to like people who aren't following along and just kind of want to see how the design process looks, like 360 streaming, I think would be so nice. But one day when I have a lot of money, whenever that happens, then I'll purchase a badass machine, and then I'll be happy. Let's see. Okay. Started early. Yeah, Mac, this will be, this is all recorded, so that works. I'm just streaming through a bunch of this. Or what did I just say? I'm reading through a bunch of this right now. Let's see. Chef. Yeah. Let me scroll down. Yeah, neat. I'm loving that there's a lot of chat activity because that makes me super happy when I see that. Because that means that people are connecting with each other, and then it's just super awesome all around, because that's really what I want to enable. Is like I want to enable that a lot of people are working on cool stuff, and it's exciting. But yeah, if there aren't really any other further questions, yeah, we're about hour and a half in, and we've built a lot. We've definitely built a lot in that, and we have very basics of Holoball. Obviously, the environment's not the same. I kind of wish we had done the specular, and I'm not going to build it now because it'll take too long, and I don't want it to. I actually dropped the bake resolution down just so that it would actually render now that I look at it. Um, and yeah, it would probably take like 20 or so minutes. No, 10 minutes maybe for it to actually finish baking, but that's just life. Um, Pulling up an animation blender. Cool. Yeah. So I might end the stream here, and yeah, if you guys have any questions, I'll definitely stick around in the chat and try to help out with that. But yeah, if you learned something or enjoyed this, then help us out by leaving a like on the video or just subscribing, because that just lets us know it's helping out a lot of people. And yeah, you can also follow us on social media. I've started posting a lot more on there because I've noticed that there's just a lot of cool stuff happening around, and I think it's just neat to share that with a bunch of people. So yeah, that works too. And other than that, yeah, we'll just stick around in the chat for a little bit, and hope you guys enjoyed. This has been FuseMan, and I'm signing out. Later, guys.